Hello guys, I hope you are doing well. I will start a very short lecture about for example, the guideline for energy saving in the factory. I should emphasize that this is not, for example, very detailed investigation for energy saving in the food factory. In the very short lecture, and also I explain you that several, for example, approach that you can reduce the energy usage in the food factory, and beside that, for example, replacement of the renewable energy resources, non-renewable energy resources, but renewable energy resources. So I turn on the laser pointer. I start, for example, in this slide that, for example, in general, it is a very short, for example, explanation and give you some guideline. And that, for example, I emphasize on the two types of the energy, electricity and heat, because as we know, the majority of energy we need is divided into two types, electricity and heat. And I explained to you what should we do, for example, in the food factory. For example, for electricity, rooftop or carport solar PV system can supply a large part of the on-site power demand. This is especially useful for refrigeration and processing equipment. However, the factory still needs to stay connected to the grid to ensure reliable and continuous operation. And also for the thermal energy, food production as usual requires a lot of heat, and solar thermal system can provide a heat. And the solar thermal system can provide heat for the medium temperature processes and help reduce the use of the fossil fuel. Another very important solution is the, for example, waste heat recovery. Food factories release a lot of heat from the refrigeration units, ovens, and exhaust system. This waste food can be recovered and is reused for the hot water, space heating, and or even cooling throughout absorption system. This greatly improve overall energy system. That, for example, if you use the heat in the condenser of the absorption chiller, you can produce cooling. And also, in some cases, high temperature waste heat can also be converted into electricity using an organic Rankine cycle or RC system. The main idea is integration, electricity, heating, and cooling should be managed together at one energy. Let's have a look of the heat recovery strategy for the net zero food manufacturing. In the food factories, a refrigeration system run all the time and release a lot of low temperature heat. This heat is usually wasted and it can be recovered using heat exchanger to produce hot water. For example, around between 14 to 60 centigrade. This hot water can be used for cleaning, CIP, washing, or heating water before it enters the boiler. To use this low temperature heat, better heat pump can also be added. Heat pumps can increase the temperature to about 18 to 120. It means that after we recover the heat and the hot water produce and its temperature ranges between 40 to 60, we can use the industrial heat pump to increase it between 80 to 120. This higher temperature heat can be used for pasteurization, sterilization, or making a low pressure steam. And also natural gas like CO2, ammonia, and propane are preferred because they are efficient and better for the environment. That you can use this for the industrial heat pump as a working fluid, as a working fluid. For the hotter waste heat, such as exhaust gases from the oven, dryers, or boiler, a special heat exchanger can recover heat before it goes into the air. If there is enough high temperature waste heat, an oncurring Rankine cycle with the abbreviation of the ORC system can turn and, for example, some of the heat can be converted into electricity. This helps improve overall efficiency and support net zero goals. The main idea is to use the energy step by step, matching the heat temperature to the right process to reduce energy waste and improve efficiency. And also about the energy efficiency pathway for the net zero food plant. Beside the renewable energy, improving energy efficiency is very important for reaching net zero in food plants. Industrial heat pumps can, for example, can replace gas boiler for low and medium temperature processes. Modern heat pump can produce hot water or process heat up to 90 centigrade and sometimes even higher. When they use renewable electricity, they greatly reduce energy use and emission. It means that we replace the gas boiler with the industrial heat pump, and also the electricity of the industrial heat pumps can be met by the renewable energy resources such as photovoltaic cell. And also the electrifying heating system is an important step for reduction carbon emission. Instead of burning fossil fuels, factories can use electric system, especially when combined with the on-site solar PV. That is, for example, oh, I should turn on the ring. Anyway, that's renewable. And the processes that need higher temperature steam or during peak demand, electric boilers, e-boilers can provide fast and flexible steam production. They are useful as a backup system. That it means that we replace the gas boiler that which are used with a higher temperature with the e-boiler. A hybrid C and also a hybrid C system works very well. For example, heat pumps supply the base load and the electric boilers cover the peak demand. This improves flexibility, efficiency, and reduces the carbon emission. The main idea is choose the right technology for each temperature level and also the energy demand. As I said to you previously, this lecture is very, very short. I hope you have a nice night and goodbye.